Hello my dear students, in this lecture we are going to see single plate clutch. Now here the schematic view of single plate clutch is shown in the diagram. Now here it is a IC engine where power is generated. Here it is a IC engine, and this IC engine topic you are going to see in thermodynamic subject, that is IC engine, where power calculations you are going to do, right, in thermodynamics lecture. Now here for IC engine, it is a cylinder of IC engine. Therefore for cylinder I am writing C. It is a cylinder of IC engine. Now here it is a piston of IC engine P. Here it is a piston rod PR. Now it is a connecting rod CR, and it is connected to the crankshaft. It is connected to the crankshaft, right. Here for this total arrangement is called IC engine. Means cylinder, inside cylinder piston is reciprocating, and piston is connected to the piston rod, which is again connected to the connecting rod, and from connecting rod power is transmitted on the crankshaft. This total arrangement is called IC engine. Now this topic you are going to see in thermodynamics. Now this crankshaft here, this crankshaft is rotating with some angular velocity omega, right. Let us say it is rotating with some angular velocity omega. Now on this crankshaft flywheel is connected. On this rotating crankshaft flywheel is connected. Now the flywheel is nothing but flywheel is used to store the energy whenever energy is in excess, and whenever we need energy, this flywheel is used as a supplier of energy. Means whenever energy is in excess form, flywheel will store the energy, and whenever energy is required, then flywheel will supply the energy to remaining parts of the machine element. Now again there are the steel plates. These are the steel plates which are also called clutch plates. These steel plates are also called clutch plates, steel plates, or we can say clutch plates, right. Clutch plates. On these steel plates there is a friction material. Here it is a friction material, right. Therefore having friction lining, having here friction lining, or we can say friction material, friction material or friction lining, right. And it is a friction clutch. Single plate clutch is a friction clutch. There is a spline shaft. It is a spline shaft, right. Now here it is a spline shaft, spline shaft. Now on spline shaft the clutch plate is mounted. Now here it is a pressure plate. Here it is a pressure plate. This plate is called pressure plate. This plate is called pressure plate. Now this pressure plate will exert pressure on the clutch plates or steel plates, so that the clutch initially, if a force on the pedal is not applied, here it is a pedal, here it is a pedal on which we are applying force for clutching purpose. On this pedal we are applying force. This force is applied so that clutch will be disengaged. Now whenever force is not applied on the pedal, now this pressure plate will exert pressure on the clutch plates, so that the clutch will be in engaged position with the engine, right. And spring mechanism, here spring mechanism is used to exert the pressure, right. Here the springs are connected. These are the springs. These are the springs. Over here also there are the springs. Springs are these springs are exerting pressure on the pressure plate or force on the pressure plate, and this pressure plate is exerting pressure on the steel plates, so that this steel plate will be in contact with the flywheel, right. And flywheel is connected to the crankshaft, and crankshaft is connected to the engine. Means whenever force is not applied on the pedal, then they are in engaged position. Means if force is equal to 0, clutch is engaged, clutch is engaged, and power is transmitted from engine to the other parts of machine element, right. Now this pedal is connected between two collars. Here these are the collars, these are the collars, and here again power is transmitted to the clutch shaft. It is a clutch shaft, right. This is a schematic arrangement of clutch, single plate clutch. Now here, whenever force on the pedal is applied, if I apply force on the pedal, then motion of pedal will be like this. This pedal will move downward, and if this pedal moves downward, these collars or these springs will move towards right. The springs or collar will move towards right, means pressure plate will move towards right whenever spring force or pedal force is applied. Because of this pressure plate will move back, so that the clutch will be disengaged from the engine or flywheel, right? Means whenever force is applied, whenever pedal force is applied, clutch is in disengaged position, right? And and the purpose of this clutch is to transfer the power at the will of operator. From engine, power is transmitted to the other machine parts at the will of operator with the help of clutch. Whenever pedal force is applied, then engine is disconnected from the rest other parts of the any vehicle. Now here our target is to do analysis of these steel plates or friction plates. These steel plates or friction plates, and this arrangement is called clutch arrangement. This arrangement is called clutch arrangement, right? Now, if we see the schematic of these steel plates, then these are the circular plates like this, hollow circular plates like this. Let us say this is a plate. Let us this is a plate having this center. Now, and here there is a friction lining. Here it is a friction material on this plate. It is a friction material on this plate, right? This is a friction material. Now, friction lining we can say, or friction material we can say. Now they are having some inside radius, Ri, and outside radius as Ro, right? And these plates will be having some thickness T, If we see another view, right, of these plates, then these plates will be having some thickness T, and these are hollow plates. Means material, this is a friction material, this is a friction lining or friction material, we can say friction material or friction lining, right? Now on these steel plates there is a pressure acting, right? As well as there is a spring force W, as well as in axial direction there is a spring force W. Now for these steel plates we are going to do analysis now. Now for these steel plates, let us say inside radius is Ri, outside radius is Ro, and inside radius is Ri, right? Now here there is having friction lining, that is friction material. On this there is a friction material, and in side view it is a friction material, right? It is a friction lining, or we can say friction material. Now for this steel plate there is a pressure acting on the plate, let us say this is a pressure acting on these plates, right? Now this is a pressure P on the plates, acting on the plates, as well as there will be a spring force normal to the plates. This is a spring force W, or normal reaction, we can say normal force acting on the plates, right? Now here the radius is changing uniformly from Ri to Ro. We can see the radius is changing uniformly from inside radius to outside radius. Here P is the pressure, W is a normal reaction or spring force exerted on the plate, Ri is inside radius, Ro is outside radius. Now this disc is rotating with some angular velocity omega. Let us say it is rotating with some angular velocity omega. Therefore, if I consider upper point, this upper point is, let us say, moving with velocity v1, and lower point on the plate is moving with velocity v2, right? Now what is linear velocity? Linear velocity is equal to r omega. Therefore v1 is equal to outside radius into omega, and v2 is equal to inside radius into omega. Therefore as radius increases, velocity goes on increasing. Therefore v1 is on outside radius, that is outermost circumference, and v2 is for innermost circumference. Therefore v1 is more than v2, as outside radius is more than inside radius, right? Means the velocity is different, but angular velocity is same. The linear velocity is different, but angular velocity is same. Now here, for a calculation of the single plate clutch, we have two criteria. That is, number one is uniform pressure theory. Uniform pressure theory. Pressure theory. Uniform pressure theory means the pressure acting on friction lining is constant throughout. The pressure acting on friction lining is constant throughout. Then such theory is called uniform pressure theory. And in uniform pressure theory, it is used for new clutches. Whenever clutch is new or friction lining is new, for new friction lining, uniform pressure theory is used, or is also called for new clutch. Now, whenever clutch is new, then it is the friction lining is not warm out yet. Therefore, pressure acting at each and every location is same. Therefore, for new clutches, always uniform pressure theory is used. But as clutch becomes old, clutch becomes old, then this friction lining will warm out. Friction lining will warm out, right? Warm out means there will be a these friction linings will warm out. And if I see how they are going to warm out, right? If I see, let us say in large view, this is a clutch plate. Now, during initial condition, the wear rate, see, wear rate is directly proportional to P into R, that is product of pressure and radius. Means this wear rate, can I say wear rate is directly proportional to pressure as well as radius. It is directly proportional to pressure as well as radius. And as radius goes on increasing, wear goes on increasing. Therefore, the outer surface, this outer surface will warm out first, right? Therefore, here the warming or wearing will start from the outer surface, right? This will warm out like this, right? And because of this, on outer surface, pressure decreases. As it is warming out, on outer surface pressure decreases, on inner surface pressure becomes maximum, right? Now, therefore, for old clutches, uniform wear theory is used. That is, second theory is uniform wear theory. And this theory is used for second type of old clutches. And as per this theory, pressure into radius, this product is constant. Pressure into radius, this product is constant. First of all, we will solve the numerical with the help of uniform pressure theory. Let us solve this derivation with the help of uniform pressure theory. Uniform pressure means pressure is constant. Pressure is constant, and this is used for new clutches, right? Now here, see, radius is uniformly varying. Radius is varying here. Radius is changing from Ri to Ro. Therefore, for such numerical, we have to solve with the help of, we have to consider very small element. Here I am considering very small elemental ring. Let us consider a small elemental ring at radius r of thickness dr. Here I am considering very small elemental ring at radius r of thickness dr. This elemental ring is having thickness, let us say dr. Thickness of this ring is dr, very small thickness dr. Now let us say here we have considered very small elemental ring like this. This elemental ring we have considered at radius r of thickness dr. Now what will be the area? If I open this ring, what will be the length of this ring? 2 pi r, that is circumference. The length of this ring will be 2 pi r, that is circumference, and thickness is dr. This thickness is dr. Therefore, area of this small ring, that is very small area, dA, because we are considering very differential element. For differential element, the very small area is, can I say, 2 pi r dr. This is very small area of this elemental ring, right? Now, on this elemental ring, we will see normal load on elemental ring, normal load on small elemental ring, right? Therefore, on this small elemental ring, the normal load will be very small, dw, which is nothing but, can I say, pressure is nothing but load divided by area. Therefore, load is equal to pressure into area. Therefore here I can say pressure into area of this small elemental ring. Therefore very small load dW is equal to pressure is constant, P is constant, P into area is 2 pi r dr. This is the small normal load acting on the ring, or we can say small normal load acting on the pressure plate, or we can say steel plate, or we can say clutch plate, right? Now what is friction force? Now force friction force is nothing but mu times normal load, mu times normal load. Now here friction force is equal to mu times normal reaction, right? Therefore for this very small elemental ring, very small friction force will be equal to mu times very small normal load dW, right? Therefore this small friction force is equal to mu into dW is P into 2 pi r dr, right? This is the friction load acting on the ring. Now can I say torque? Torque is nothing but friction force into radius. Torque is nothing but friction force into radius. Therefore on this small elemental ring, very small torque dt, very small torque dt is equal to very small frictional force dfr into radius. Therefore dt is equal to mu p 2 pi r dr into r. Therefore very small torque is equal to this r into r square, right? Therefore it becomes 2 pi r square into mu p dr. This will be the very small torque acting on the ring, very small ring that we have considered. So as per uniform pressure theory, that is pressure is constant, very small normal load on the ring is P into 2 pi r dr, and very small torque transmitted is mu P 2 pi r square dr. Now here radius is changing from initial radius Ri to outside radius Ro. Therefore for such type of variation, here radius is varying or not, R is varying from Ri to Ro. For such type of variations we have to integrate. Therefore for total torque we have to integrate, right? Integrate both side. Therefore integration dt is equal to integration mu p 2 pi r square dr. Now here integration of total torque is t, and radius is varying from initial ri to ro. Therefore put the limits of radius ri to ro. Therefore total torque is equal to that mu, coefficient of friction is constant, P is constant as per uniform pressure theory, 2 pi is constant, therefore it will come out. Therefore mu P into 2 pi integration of Ri to Ro r square dr. Now what is integration of r square dr? That is r cube divided by 3. This is the integration of r square dr. Therefore put here. Therefore total torque is equal to mu P into 2 pi, here r cube divided by 3, and r varies from ri to ro. Therefore put the limits. If I put limits, therefore total torque is equal to mu P into 2 pi ro cube minus ri cube divided by 3. I hope you know how to put the limits. It is very simple. From 12th standard you are doing this in mathematics, right? Now here first of all we have to find the pressure. In terms of pressure, this is the torque formula, very important. Remember this formula. In terms of pressure and Ro and Ri, this is the torque transmitted formula. Now in terms of normal load W, we will derive this formula. Now on this small elemental ring, what is very small normal load? It is P into 2 pi r dr. Therefore very small dW is equal to P into 2 pi r dr. Now if I want to find total load, integrate both sides. If I integrate both sides, then from integration from initial Ri to Ro limits, therefore total load acting is equal to P is constant, 2 pi is constant. Now integration of R with respect to dr is nothing but R square by 2, right? Therefore here R square by 2 and limits Ri to Ro. Therefore total load, normal load W is equal to P into 2 pi, put the limits Ro square minus Ri square divided by 2. This is the total load W. Now here in numerator 2 and in denominator 2, 2 will get cancel, and if I derive for P, pressure is equal to W divided by pi RO square minus RI square, which is nothing but area, projected area. This pi RO square minus RI square is a projected area of this ring or cross section area of this total disc, right? This will be the pressure. Now put this pressure in a torque equation. Put this pressure in a torque equation. Hence we will get T is equal to mu. Instead of P, put this. Therefore mu into W divided by pi RO square minus RI square into 2 pi into bracket RO cube minus RI cube divided by 3, right? Now again, therefore torque is equal to, see, 2 by 3 mu W. Here pi will get cancelled, right? In bracket RO cube minus RI cube divided by RO square minus RI square. This is the torque transmitted as per uniform pressure theory, that is pressure constant. As per uniform pressure theory, this is the torque transmitted. Now what is torque? Torque is nothing but friction force into radius, right? Now here equate this formula, and friction force is nothing but mu times normal reaction, mu W, right? Therefore torque, we can say torque is equal to friction force mu W into mean radius of friction, Rm. Mu W Rm, where Rm is mean radius of friction, right? Therefore equate this torque with mean radius of friction. Therefore can I say, by equating these two equations, we will get mean radius of friction is equal to 2 by 3 RO cube minus RI cube divided by RO square minus RI square. This is a mean radius of friction as per uniform pressure theory. Very, very important. Very important. Now let us solve with the help of uniform wear theory. Now for very small load, normal load dW, we have solved this. dW is equal to P 2 pi r dr, and very small torque transmitted is mu P 2 pi r square dr. Now second theory we are going to see is uniform wear theory. Now here wear rate, this wear rate is directly proportional to product of pressure and radius. Means for this plate, let us say this is a plate having some thickness T, right? For this plate, here there will be an inside radius Ri, this is the inside radius Ri, and there is an outside radius Ro. Therefore outside radius is maximum radius and inside radius is minimum radius, right? Now if pressure is acting, the outside surface will wear out first. Like this. The wear will start from the outside surface like this, and the pressure distribution will change from, at inside surface there will be a maximum pressure, and on outside surface there is a minimum pressure, and uniformly pressure is changing here because radius is uniformly changing. On outside surface minimum pressure, at inside surface there is a maximum pressure, and on outside surface there is a minimum pressure, because uniform wear rate means PR is constant. Therefore if pressure is increasing, radius is decreasing, and if pressure is decreasing, radius is increasing, right? That means we can say pressure is inversely proportional to radius. Therefore for maximum pressure, radius must be minimum, and this is equal to, for minimum pressure, radius must be maximum. That is maximum pressure into minimum radius is equal to minimum pressure into maximum radius, and maximum radius is outside radius, minimum radius is inside radius, right? Now here this theory is used for old clutches, that is if friction lining is old, then this theory is used. Now as per this theory, PR is constant, therefore pressure is equal to constant divided by R. PR is constant, therefore pressure is equal to constant divided by R. Now we will use this theory for calculation of torque. Now what is torque? dt is equal to, torque transmitted by a very small elemental ring is dt is equal to mu p into 2 pi r square dr. Now see, can I write this torque is equal to mu into p into r into 2 pi r square divided by r dr, because here I have multiplied with r, divided with r, right? Therefore this very small torque dt is equal to 1 r will get cancelled here, r and r square, 1 r will get cancelled, therefore it will become mu into PR into 2 pi r dr, and PR is constant, therefore is equal to mu c, PR is constant na, into 2 pi r dr. Therefore this is a very small torque transmitted by the elemental ring, which is equal to mu into c into 2 pi r dr. Now if I want to find total torque transmitted, I have to integrate both sides. Therefore integrate both sides, integration dt gives total torque is equal to integration mu c 2 pi r dr. Now here radius is variable, therefore radius is varying from inside radius ri to outside radius ro. Therefore consider the variation of radius from ri to ro. Right, now solve this. If I solve this for total torque, then torque is equal to mu is constant, c is constant, 2 pi is constant, integration of r dr, and radius varies from ri to ro. Now integration of r dr is nothing but r square by 2. Right, therefore put here, therefore torque is equal to mu c into 2 pi into r square by 2, radius varies from ri to ro. Now if I put the limits, then torque will become, torque is equal to 2 pi mu c into ro square minus ri square divided by 2. This will be the torque transmitted, where c is nothing but constant, which is nothing but PR is equal to maximum pressure into minimum radius is equal to minimum pressure into maximum radius. Right, this is the c value. Now if I convert this c in terms of weight W or normal load W, now normal load dW is nothing but P into 2 pi r dr. Right, now here as per uniform as per uniform wear theory, the product of pressure and radius is constant. Therefore can I say here product of pressure and radius is constant, therefore dW is equal to 2 pi c into dr. Right, now integrate both sides for getting total load, therefore integration. Right, now here W is equal to 2 pi c, integration of one is r, and this radius varies from ri to ro, therefore put the limits from ri to ro. Therefore W is equal to 2 pi c into ro minus ri. Therefore the constant is, this c is equal to W divided by 2 pi ro minus ri. Again this is very important. Right, now put this constant in torque formula, put this constant in torque formula. Therefore torque is equal to 2 pi mu, instead of this constant c put this. Right, therefore W divided by 2 pi ro minus ri into ro square minus ri square divided by 2. Right, now let us solve this. Therefore torque is equal to, here 2 pi will get cancelled. Right, therefore it will become mu w in bracket ro square minus ri square divided by ro minus ri. Now here ro square minus ri square we can split like mu w ro plus ri into ro minus ri. Here divided by 2 also, here it is divided by 2 also here. Right, divided by 2 ro minus ri. Now here ro minus ri from numerator and denominator will get cancelled. Right, this will get cancelled. Therefore the answer will become torque is equal to 1 half mu w ro plus ri. Right, this is the torque transmitted as per uniform wear theory, uniform wear theory. Now if I want to write this torque in terms of, this torque is nothing but mu w, friction force, into mean radius of friction, Rm. Therefore if I equate this, then Rm will become Ro plus Ri divided by 2, which is called mean radius of friction, mean radius of friction, which is again algebraic mean. This mean radius of friction is algebraic mean as per uniform wear theory. So let us write summary of this uniform pressure theory and uniform wear theory. Number one, as per uniform pressure theory, uniform pressure theory means pressure is constant, and as per this theory, torque transmitted is 2/3 mu w RO cube minus RI cube divided by RO square minus RI square, and which is equal to mu W Rm. Rm is mean radius of friction. Therefore, mean radius of friction becomes 2/3 RO cube minus RI cube divided by RO square minus RI square. This is the mean radius of friction. And pressure, constant pressure is equal to W divided by pi Rho square minus Ri square. This is as per uniform pressure theory. Now, second, we will see uniform wear rate theory. Uniform wear rate or wear theory. As per uniform wear theory, product of pressure and radius is constant. Product of pressure and radius is constant. That is means constant is equal to PR is equal to P maximum into R minimum is Ri is equal to P minimum into R maximum is Ro. Right. Now, and this constant is calculated as per uniform wear theory, this constant is calculated as W divided by 2 pi Ro minus Ri, where W is normal load acting on the plate, right? And torque transmitted is equal to, torque transmitted is 1 by 2 mu W Ro plus Ri, and if I equate with mu W Rm, then we will get mean radius of friction as per uniform wear theory is Ro plus Ri divided by 2. And we have seen uniform pressure theory is used for new clutches, and whenever clutch becomes old, then uniform wear theory is used. Right. Now, generally, the maximum life of clutch is in old condition. Therefore, for safer side, always try to use uniform wear theory if in question nothing is mentioned. If in question they don't mention you which theory we have to use, then always use uniform wear theory by considering old clutch. And whenever uniform pressure theory is particularly mentioned in the question, then only go for uniform pressure theory. Now let us consider this torque is equal to mu W into mean radius of friction, right? And we have mean radius of friction for uniform pressure theory as well as uniform wear theory, right? Now for any radiuses, let us say for same radia, that means for same value of Ro and Ri as per uniform wear theory and uniform pressure theory, consider any values. Let us say outside radius I am considering 20 and inside radius I am considering 10. Consider any values, and by putting Ro and Ri in mean radius in as per uniform pressure theory and in mean radius as per uniform wear theory, you calculate the values. Then by calculation you will find that the mean radius as per uniform pressure theory is always more than mean radius as per uniform wear theory. This will be the relation always for same radius, right? For same radia. Therefore, can I say as mean radius is increasing, torque transmitted is also increasing. Therefore, for same radia, torque transmitted by uniform pressure theory is always more than torque transmitted by uniform wear theory. And as obvious, for new clutches we are using uniform pressure theory, and for old clutches we are using uniform wear theory. And as obvious, new clutch will always transfer or transmit more torque as compared to old clutch. The same we are proving here, right? Means the important points are, whenever the maximum life of clutch is under old condition, therefore if nothing is mentioned in the numerical, then always try to use uniform wear theory. And if particularly uniform pressure theory is mentioned in the question, then use uniform pressure theory. And if same radius are given, that is inside radius and outside radius for same, the mean radius of friction as per uniform pressure theory is always more than mean radius of friction as per uniform wear theory. Therefore, torque transmitted by uniform pressure theory is more than torque transmitted by uniform wear theory. Thank you, dear students. In next lecture, we will see multiplate clutch.